Welcome to Revision Week 16. This week we are looking at images, metadata and compression, which is all part of paper 1. Make sure you've got sheet 16 with you ready to follow along and complete. Okay, let's have a look starting at images. So remember we've looked and recapped about how binary is used to store everything on the computer, such as numbers, and character sets where every character has a unique code. But how does it work with images? Well, images, particularly bitmap images we are looking at, are made up of tiny blocks of colour called pixels. So when you zoom in, you can see these pixels enlarged. A pixel is a single block of colour, one colour. And a bitmap image is a image or graphic made up of pixels, and each pixel has a single colour stored as a unique binary number. Every single pixel is stored with a unique binary code. Images themselves have a height and the width made up of pixels, and that is the dimensions, the height and the width of the image in pixels. And you can use that to work out the total number of pixels by multiplying them together. You also have the color depth, which is the number of binary bits that is stored for each pixel. With only one bit for each pixel, you can have two colors, 1 or 0. So it could be black and white, for example. With 2 bits, you can have 4 colors because there's 4 combinations. 3 bits, you can have 2, 4, 8 bits, 8 colors. Then 4 bits, 16, all the way up to 8 bits, 2, 5, 6 and beyond. The more colors you need, the more bits you have to store for each pixel. But the larger the file size becomes. And most photographs that are taken on the cameras are stored as 24 bit. 24 bits. That's 8 bits for each red, green and blue values of colour. So you can see here, look, the higher the colour depth, the better the colour range or the more colours are available. And as you reduce it, less colours become available. The file size gets smaller, but less colours are available, so the image appears to be worse, but it's actually just less colours. We've also got the resolution, the number of pixels that are in the image. You can see here on the left hand side a higher resolution image with more pixels, down to C on the right with less pixels. The pixels are larger because there's less of them. So the resolution is the number of pixels in an image, for example pixels per inch. Higher the resolution, the better the quality, but the more data there is to store and the larger the file size. And again here you can see high quality 72 dpi, 72 pixels per inch. And as we reduce that, the photo starts to look worse and worse and worse because the pixels are getting larger, there are less of them. So the quality appears to be worse, but the file size would also get smaller in this case. So we've got pixel, a single block of colour. The dimensions, the height and the width. The resolution, the number of pixels in the image. The colour depth, the number of binary bits stored for each pixel. On the sheet, fill this in before ready to check. Pause and do this now. Okay, time to check your answers. So here we are. Bitmap, an image made up of pixels. Each colour has a single colour, which is stored as a unique binary value. This question here could easily come up in the exam if you asked what a bitmap image is or an image, how it's stored. Pixel is a single block of colour in an image. Dimensions, the height and the width of the image in pixels. Colour depth, the number of bits used to store each pixel. And you've got the amounts here. 1 bit is 2, 2 bits is 4, 3 bits is 8, etc. Resolution, the number of pixels in the image. And what does increasing the resolution do? The higher the resolution, the more pixels and detail, better quality, but larger the file size because more binary data has to be stored. Okay, let's have a look at metadata. So remember, every file that's stored has information stored with it. That is the metadata. It's data about data. It's the data that's stored with a file which gives it information about the properties of that file. The data stored with a file about its properties. Data about data. When working with images, there are some data that is essential to show the image, just as the file format. Is it a JPEG? Is it a PNG? You've got to have the dimensions, the height and the width, so you can recreate it. You've got to have the color depth, so it knows how many colors and bits are used, and you've got to store the resolution. These are essential to show the image. There are other non-essential data that you can store with it, such as the date when the photo was taken, the camera settings used, the name of the creator, and many other different settings. But they are not essential. You do not have to have them. Having a look at this image here, if you right click, you can see and go to properties, there are loads of metadata. There's the essential basic stuff, such as the bit depth, the resolution, etc., the dimensions. And there's also lots of different additional metadata here, such as the camera settings used and the title, etc. So, metadata, data about data. Some essential, some non-essential. Complete this section of the sheet now. What is metadata? Examples of essential and non-essential. Pause and complete. Okay, ready to check. Here we go again. Data about data, the data that's stored with a file about the file's properties. And we've got essential ones, file format, height, width, color depth and resolution. Non-essential ones such as the data, a photo was taken, camera settings, name of creator, etc. Final one today, compression. This is all about images we are looking about. So compression is when you make the file size smaller. You are trying to reduce the size of the file. Why? So it takes up less storage space, so it can be streamed or downloaded quicker from the internet, and is much easier to send by things like email for attachments. There are two types of compression we need to know about for images and sound and things. That is lossy compression and lossless. Lossy compression works by permanently removing some of the data from the file, usually like colours that can't be seen by the human eye and data that's not essential from the image. However, the more you compress it, the more noticeable it becomes. You can see at the bottom here, as you reduce the quality of the image or the resolution, the file size is getting smaller, but the quality of the image is also being reduced. Less colours, less pixels, etc. It can be used on sound and images, but it cannot be used on text or software, because if you start deleting text or code from the things, it would not make sense, it would not work. Good things about lossy, it greatly reduces the file size, and there are very common file formats. However, the reduction is permanent. You cannot get the original quality back again once it's been compressed, and you cannot use it on text or software. The second type is lossless. Lossless is when you temporarily remove data, but you can fully restore it to its original quality at the end. So it's only temporarily reduced. There's no reduction in the quality overall. And it can be used on text and software too. However, cons, there is only a slight reduction in the size of the file, only a small amount of reduction, so not nearly as much as lossy. Okay, final section to complete. On the right hand side, compression, lossy and lossless. Pause and do this now. Okay, time to check your answers. Lossy on the left here. Compression that permanently removes data from the file. The original quality cannot be fully restored. It's permanent. File type examples include JPEG, MP3, MP4, JPEG for images, MP3 for sound, MP4 for video, or MPEG. Advantages: greatly reduce the file size, Disadvantages: you cannot fully restore the original and it can't be used on text or software. And lossless temporarily removes data. File can be fully restored by opened or uncompressed. File types include PNG for images or TIFF, and FLAC for sound. Advantages: there's no reduction in quality, you can get the full quality back, and it can be used on text and software. Disadvantages: only a slight smaller reduction in file size, much smaller than Lossy. Okay, to finish off, as always, go to LearnCoding, the revision section, and complete revision quiz 16 for this week. Check your answers, make sure you redo questions you don't. You should be aiming for 100% as always. Good luck, see you in lesson.